This method is used to replace damaged or missing circuits on the circuit board surface. The minimum skill level needed to complete this procedure reliably is advanced. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. The procedure follows. Step 1. Clean the area. Step 2. Remove the damaged section of the circuit using the knife. The damaged circuit should be trimmed back to a point where the circuit still has a good bond to the PC board surface. Step 3. Use the knife and scrape off any epoxy residue, contamination or burned material from the board surface. Step 4. Scrape off any solder mask or coating from the connecting circuit. Step 5. Clean the area. Step 6. Apply a small amount of liquid flux to the connection area on the board surface and tin with solder. Clean the area. The length of the overlap solder connection should be a minimum of 2 times the circuit width. Step 7. Select a replacement circuit with film adhesive backing that most closely matches the size of the conductor to be replaced. If a special size or shape is needed, it can be custom fabricated. Note: new conductors are fabricated from copper foil. The foil is plated on the top side with solder, and an epoxy bonding film is applied to the bottom side. Step 8. Before trimming out the new conductor, carefully scrape off the adhesive epoxy film from the solder joint connection area on the back of the new conductor. Use caution. Scrape off the epoxy backing only from the joint connection area. When handling the new conductor, avoid touching the epoxy backing with your fingers or other materials that may contaminate the surface and reduce the bond strength. Step 9. Cut out and trim the new conductor. Cut out from the plated side. Cut the length to provide the maximum allowable circuit overlap for soldering. Minimum 2 times the circuit width. Note: if the configuration permits, the overlap solder joint connection should be a minimum of 3 mm from the related termination. This gap will minimize the possibility of simultaneous reflow during soldering operations. Refer to 7.1 Soldering Basics. Step 10. Place a piece of high-temperature tape over the top surface of the new conductor. Place the new conductor into position on the circuit board surface using tape to help in alignment. Leave the tape in place during the bonding cycle. Step 11. Select a bonding tip with a shape to match the shape of the new conductor. Note: the bonding tip should be as small as possible but should completely cover the entire width of the new conductor. Step 12. Position the circuit board so that it is flat and stable. Gently place the hot bonding tip onto the high-temperature tape covering the new circuit. Apply pressure as recommended in the manual of the repair system or repair kit for 5 seconds to tack the circuit in place. Carefully peel off the tape. Step 13. Gently place the bonding tip directly onto the new circuit. Apply pressure as recommended in the manual of the repair system or repair kit for an additional 30 seconds to fully bond the new circuit. The new circuit is fully cured. Carefully clean the area and inspect the new circuit for proper alignment. Step 14. Apply a small amount of liquid flux to the lap solder joint connection area and solder the circuit foil jumper from the new conductor to the circuit on the PC board surface. Use minimal flux and solder to ensure a reliable connection. High-temperature tape may be placed over the top of the new conductor to prevent excess solder overflow. Step 15. Mix epoxy and coat the lap solder joint connections. Cure the epoxy per Procedure 2.7 Epoxy mixing and handling. Use caution. Some components may be sensitive to high temperatures. Step 16. Apply surface coating to match prior coating as required. Evaluation. Step 1. Visual examination. Step 2. Measurement of new pad width and spacing. Step 3. Electrical continuity measurement.